I have to confess, before we formally start this thing, I feel like a production manager. See, now I have to think about mics. Okay. Please do pardon me as I try to pull this off. This idea of sort of doing reflections came about, actually it was Teresa's idea, and she wanted to make it much more engaging with everybody. And I kind of agreed because we had done something similar on the 20th anniversary of MobiCom, for those of you who got there. So how many of you actually came to the 20th anniversary? Okay, a few of you did come. So if you remember, we did the same similar sort of thing with the OCA winners, 3 of them, and that worked out well. So I'm hoping, fingers crossed, this will work out well. Okay, but I'm using some tech here, so I'm not very good at tech. So that was supposed to be a joke. I'm actually pretty good at tech. Okay, doesn't matter. All right, okay, so let's start. I want to say a few words about Teresa. I'm going to read you a few things that Marco showed when we first, in the inaugural session, but there was so much going on that it wasn't clear to me if you were digesting some of that stuff. So I'm going to just read a few things to you. And these are people who know her and have written things about her. And of course, they wrote lots and lots of great accolades, but just the representative ones here. So it says, Teresa's broad contributions to wireless technologies have a remarkable breadth, spanning digital signal processing algorithms, CMOS design, wireless networks protocols, Wi-Fi, and it goes on and on. The main driver of today's low-cost performance, low-power, high-performance Wi-Fi that has realized is her vision of ubiquitous access, connectivity to everybody, and doing it in a way that it is inexpensive to everybody. She's an exemplary technical leader and innovator. She is a pioneering contributor. The Atheros miracle is amazing, and you will get to know a little bit more about it as we do this. She's incredibly inspiring and uplifting advisor. This is her students writing about her, and many of them have gone on and pursued very, very successful careers themselves. She's a role model and inspiration to everyone. And I was the person who wrote this says I was very, very fortunate to have to work with her. As the award goes, there's some recommendations. So people were talking about how this award was so long overdue to her, and how great that was. And my hope is that by the end of this session, you will appreciate for yourself why Teresa was chosen for this award and what a remarkable individual she is. Now, let me tell you a little bit about her. Okay, so she is the first female professor in electrical engineering in Stanford. I think that is a pretty remarkable thing. She got her Bachelor of Science degree from NTU, National Taiwan University, in '83. She got her master's and PhD in electrical engineering from University of California, Berkeley. She's a Reed Weaver Dennis Professor of Electrical Engineering at Stanford University, where she was, and still is actually, but 1988 to 2013, after which I think she retired, but she's still associated with the university, so she's Professor Emerita in Stanford. She's the founder and director of Atheros, as most of you know, Atheros Communication, which was from 1998, and she served as the CEO, director, lead designer, engineer, pretty much everything you need to do to make a company stand up and do amazing things. She's the director of the Computer Science Telecommunication Board in the U.S. National Academies from 2003 to 2009. She's a trustee of the U.S. Computer History Museum from 2006 to 2008. She's in the advisory board of Atmospheric Technology and the board of director of Umbrella. And this actually happened very recently, as far as I know, that she accepted that position. Now, she has also won a lot of awards, And I'm not going to go through all of them, but just I do still want to give you a sense of the kinds of things, awards she's won. So she's won the Distinguished Alumni Award from her alma mater. So she got a bachelor from NTU, so she got a Distinguished Alumni Award from there and from Berkeley. So in Berkeley from 2010 and NTU also 2010. She got a Lifetime Achievement Award, demo. An IEEE Donald Peterson's Award in Solid State Circuits. This was in 2009. She's in the National Academy of Engineering. This is one of the highest honors we give to people who we believe have done some significant work in engineering in the US. She got the 2020 Vision Award by the CIO magazine, very, very aptly. She got the Innovator of the Year MIT Sloan Business School Award when they saw what an amazing entrepreneur she was. She was named the top 10 Entrepreneurs of the Year Award by Red Herring. She obviously, well, I say obviously, but she's an IEEE fellow. She also, in her earlier years, when she was a young professor, got the NSF Presidential Young Investigators Award and the ONR Young Investment Award earlier on. So, as you can see, quite a remarkable individual with people who admire her quite a bit, and she did us proud. And we are very happy to see her as the OCA winner this year. So let's have a hand of applause for Teresa Meng. Okay. So, Teresa, please have a seat. So the way this is going to go, I just sort of want to let you know, is we've designed this as a fireside. So the way this is going to go is I prepared some questions. I was thinking about reading up on her life and her story, and I'm going to ask those questions. But I also want, and she actually wants, to engage with the audience. So at some point, I will stop, and I will turn it over to you guys, and you will then ask her some questions. Hopefully you will have some interesting questions to ask. And then we will switch it back to me, where I'll have a rapid-fire question Q&A. And we'll see how she reacts to that. And then once that's done, then we will do a little bit of award, and we'll call it quits. So, okay. So, Teresa, congratulations once more.
Thank you very much. I really want to thank the MobiCom committee first for the committee members and also the nominators and supporters who helped me win this award. I truly feel very honored to be here to receive this award. And I actually haven't had a test for many, many years. I feel very nervous right now. As a student, say, what's going on here? And then there's a non-stop question, so let's see how it goes.
Okay. We will try to make you very comfortable.
Okay.
You just forget anybody's there. You and I will just talk.
Okay.
All right?
Yeah.
Okay. So, let me ask you, let me take you back to your childhood days.
Okay.
Right? You were a little kid growing up in Taiwan,
yeah.
studying. What influenced you to become an engineer?
Engineer, okay.
Yeah. Why did you choose engineering as a profession?
It's actually a funny story. Okay. In Taiwan, we had this college entrance examination. So that at about age of 16, we need to choose among 4 categories: science, humanity, business, and something else. I have a good friend. We were in an all-girl high school. I had a good friend. She sucked in every discipline except math. I just couldn't do math, but I was good in every other discipline. So we had a little meeting in order not to be separated. That was the whole goal back then, to stay with my friend. We decided to take the exam in the science and technology, because in science and technology, the math was given a bonus. Since I was probably more studious, whatever, so I took the hit. So we decided we're both gonna do science and technology, so she will have a chance to get into college. Yeah. And long story short, I still sucked in math in the exam. She did fine in math, but she still didn't get to college, and here I was in NTU department. So it was a friendship. I was too young to think about future. I just want to be with my friend.
You're still friends with her?
Oh, yes. She actually still lives in Cupertino. She's an at-home mom. and I'm here today. So you can see how life has played a joke on us.
So then math equated to engineering for you.
Back then in Taiwan, the number one choice in science and technology was electrical engineering.
Was there anybody in your family who was an engineer? Or
My father was a civil engineer.
I see.
Yeah, and then, but I didn't really get any vibe from him. But he did say that as a girl, since I was a child, he said, as a girl, the most important thing is for you to be financially independent. So you never depend on another man, so you can be free. So engineering was considered pretty safe.
He was pretty
job.
evolved in
Right,
some sense.
yeah. It's a safe job that I can feed myself. So I didn't object to the suggestion from my friend to say let's go for science and technology, because that was her only chance to do well in the exam.
Okay, so then let's move on. So then from there, you came to the US,
Right.
you got your bachelor's,
Right.
and then you decided to do a PhD. What
Right.
was the thinking at that point?
That's my dad again. Okay. I was just a kid in NTU, doing fine, not really having great ideas. Again, my father thought that the storyline that I had to be able to be independent. So going to the United States, getting a PhD was his idea of having a skill, having a career for myself. I really didn't want to leave home. I remember I was crying for 12 hours on the plane from Taipei to San Francisco. Yeah, and it was really tough for me. Yeah, so that was how I ended up at Berkeley.
So then you graduate,
Yeah.
and now you have a choice. You can go to industry or you go to academia. So what was the decision point? Why did you decide academia?
Funny that you asked that one. I actually was enjoying my graduate school very much. I always told my students, if you don't wake up in the morning and thinking, great, this is a new day, I can do more things, you probably don't belong here. Okay, so I did enjoy my graduate school. So I actually didn't think about leaving or having a job until my professor, David Messerschmidt, told me one day, said, Teresa, you should graduate. I said, oh, okay, what should I do? And he said, you know that when you start working, there's only 2 weeks per year for vacation. I said, that won't do. I'm used to having 3 months. And he said, then why don't you be a professor? I said, can I? I could hardly speak English back then. I said, you guys are just like gods. You teach, you really perform. And Professor Messerschmidt was such a, I would say, example professor. He said, no worry, let's work on it. So I spent 1 year, the last year at Berkeley, learning how to teach. And so I first observed these professors, how they actually make jokes. These are prescribed jokes. Most jokes are random. I observed them for half a year, kind of learn how they make sure students are interested. And then Berkeley was a very supporting environment, and the department chair actually got me a job as a lecturer because they knew I wanted to be a professor, right, for the vacation. And so I was teaching. I was actually a lecturer for the last semester at Berkeley. I was actually teaching a course by myself with 2 TAs. And that gave me the confidence to actually start teaching right away.
So I see. So this is good. I think there is a lesson here. I think for every individual who ends up reaching the stellar high, there are some people behind who push and who advise and who get you in the right place. So, okay, let's move to Stanford now. And you're a professor. You're doing well. You are very passionate about the research area you're doing. But then in 1998, you decide to take a sabbatical. And as part of the sabbatical, you decide to build a company. At that time, you were working on CMOS, and there were some performance problems there, and you believed that you could solve those performance problems. And that was not the thing in vogue at the time, I think. Wi-Fi was expensive, things were expensive. So could you please tell us a little bit about, go back to 1998, think about your young self, and tell us about what made you, first of all, tell us a little bit about what those problems were, and then what made you so confident that you could just go out there and get it done?
Okay. Actually, we started the project in about 1995. 3 years before that, it wasn't Wi-Fi didn't exist back then. The standard wasn't even rectified back then. But we worked on the DARPA project on single chip GPS, and then that was the project that we had to put both analog and digital component on a single chip, quarter micron CMOS. From that experience, from that implementation, I kind of had a hunch that, gee, we can really use CMOS to gigahertz, up to 5 gigahertz, even though GPS is about 1.6, with digital compensation. Okay, for all of you who are in the DSP, you know that we can use signal processing to correct everything that is not random. Okay, so the analog components back then in CMOS technology had various impairments, such as nonlinearity of the power amp, IQ mismatch, DC offset, but none of these are random error. These are deterministic errors. If they are deterministic errors, guess what? DSP can solve that. And so I wasn't the only one who can see that. I mean, most people work on integrated CMOS back then could have seen the problem. As a professor back then, you know what we did? We actually gave it to the industry. Okay, I started giving talks at industry and telling, for example, Cisco, Intel. I talked to the VP and say, you guys know, this is, if you believe wireless is the way people want to communicate in the future, this is the way how we're going to implement it. And they kind of agree to say, yeah, we can see this is happening. But we really, back then, that was 20 years ago, we really didn't have the expertise or know how to do it. And that would probably take 10 years to realize it, for it to have a market, and therefore we're not really invested. I said, 10 years? I can do it in 2 years. What are you talking about? This thing is being proven in my mind that it could be done. And so it was really the notion that we should not wait that long for this technology to be available to the public. I never worked in industry before, so start a company was not in my thought at all. So I talked to John Hennessy. He was the dean of school. I said, there is this thing I know. It will be the way. You know, either doesn't matter who does it, but this will be the way of future wireless communication devices. I said, what do you think? And John said, you should start a company. I said, what? Why? Then he told me that. He said, starting a MIPS that he started was the second best thing he did. And he said, you will enjoy it too. I said, okay, I'll give it a try, because obviously the industry was not interested in doing this. And it was that conversation I decided to give it a try.
That's great. And for those of you who may not know this, at the time Teresa started, Wi-Fi was about $50 per megabits per second. And because of the work she did, and others, her colleagues and others did, basically today you've got that same for 0.02 cents. So you can sort of see, and I think a lot in part was because of the tech that you built, which pushed the cost down. You wrote the Moore's law, and it's all worked out very nicely. It's
very interesting you mentioned that, because the pitch we give to VC, exactly the metrics, right? Because we have to give VC a story. What are we actually achieving? Yeah. For a startup company, we have to have orders of magnitude improvement over what? Yeah. Okay, data rate back then, yeah, we can get 100 megabit per second, really expensive discrete component chip, not chip, the whole board, you know, cost a couple $1,000s. So it was about $100 per megabit per second. So the pitch we did to the VC was we're going to reduce that to $1 per megabit per second. That was considered crazy back then. Yeah. Actually, VC, there was a story about, we can talk about how the company was formed. It wasn't easy back then, because in 1998, that was the first internet bubble. You can pretty much sell hosiery on the internet and get $5 million investment, because the VC wants a return within 6 months. And then a company like this, I told them blank that I cannot give you any financial forecast because the company won't make any money in 5 years. So
Yeah,
so it was a tough
actually,
startup.
I was going to ask you this question. There are many young students and young at heart students. So I wanted to sort of have you tell us a little bit about your journey of creating this company. So you had a lot to do. You were a professor. You now wanted to start a company. You had to raise money for it. You had to recruit talent. You had to put a management structure in it. Could you just walk through that whole process of what it took to build out Atheros? And you don't, I mean, just to sort of give a sense of what people are up against when they think about transitioning and trying to build a company.
That's a very loaded question. I don't even know where to start. Of course, Stanford had back then a lot of people starting a company. So of course, I learned a great deal from them, John Hennessy being one of my advisors there. I literally learned everything from scratch. I didn't know anything about VC. I didn't know anything about recruiting. I was just a professor. Where do I start? Recruiting. First, where do I get the employee?
Yeah, tell us about your first set of people that started with you.
Okay.
And how how you guys got together, and what were they doing and things of that nature.
Since I was a digital person, so I knew that the hole that I need to fill is the analog designer. And I contact Bruce Willey. Bruce Willey is kind of the professor who trained all the analog circuit designers in the Valley. So I asked him for recommendations. I start calling them. Okay, some of them I knew, but most of them I didn't. I call them and I sell the pitch. Well, actually, the pitch is we can talk about that.
Yeah.
And then individually, it was pretty hard because, as I said, that was the internet bubble. Nobody believed that a hardware company will actually succeed back then.
Yeah.
And actually, the biggest obstacle we ran into back then was most VC believed that the communication will be telephone line.
Yes.
There's a home run, right? There was a standard called home run. So all the local area network will be supported by telephone wires. So one of the VC even said that I don't believe this crap because God didn't intend CMOS to be operating in gigahertz. That was a quote. So it was pretty. It was a top startup in the sense of fundraising. But I think back then, to me, I mean, Andrea talked about license band. Back then, 23 years ago, the data rate was very low. And companies like cell phone company operator, they have to spend billions of dollars just to get 20 megahertz band. At the same time, about 97, 98, most countries, the government actually opened up an unlicensed band, both 2 gigahertz and 5 gigahertz. They were like several hundred megahertz a band of spectrum. Mm-hmm. To me, what I call back then democratizing the airway. I just think that people should have access to cheap or free, ubiquitous data as a basic human right. Everybody should be able to communicate without being held hostage by the cell phone company. And I think that was a compelling vision. Yeah. I think some of the engineers who I recruited from these various companies, they were not from wireless. Nobody was doing CMOS wireless back then anyway.
So when you were recruiting, did you already have money at the time? Or
No.
So you were recruiting them on literally the vision.
Yeah.
And then
right.
you were going to go and sell that vision and
right.
get the money.
In Silicon Valley back then, you had to have a team before you can actually go to the VCs. Okay, so I didn't have enough personal credential to go raise the money and say, hey, Teresa Meng want to do this. So I actually had to form a team of about 8 persons. They gave me the commitment that they would join the company when I indeed raised the money. So it was based on this notion that unlicensed band, which is a Wi-Fi right now. Back then, as I said, the Wi-Fi didn't even exist. We just called them local area network, right? Yeah. That will free, I say, unshackle the hold from the cell phone. So I was really going after cell phone company back then.
Yeah. So I have a little personal story here too. I remember sitting on panels and trying to argue that Wi-Fi, or at that time it was Wi-Fi, as you know, 802.11 was going to be the dominant over as opposed to cellular. Everybody did believe in cellular. Everybody believed that was going to be the ubiquitous technology, and I had to argue that that's actually not going to be the case. And so I totally understand what you were going through at the same time, where the dominant thinking was that. So I have one really quick thing. So Atheros started as T-span systems. So why the name change? What happened there?
T means technology, by the way. It's not Teresa. People know me, know that I would never do that. No, it's technology span. We searched for the name, and it has to be a name that has not been registered. Atheros was actually named by our first, I would say, official CEO, which is about a year and a half after the startup, after I founded the company. Atheros means the son or the daughter of Athena, the god of war and god of and Eros, the god of air. So Athero is the god of air, right? And that was
I did not know that.
Right, that was the first CEO who named that. So that
I
was
think
funny.
It's a great name.
Yeah.
It's a great name. So we, in the previous question, was sort of aimed at the entrepreneurs in the audience and young folks, or any folks for that matter, trying to develop a company or build a company. This next question is actually about the academic community. So MobiCom, the community is very, as far as I can tell, very, very keen on impact. So a lot of the work that happens is all about impact. So one of the thoughts I had was that when you were doing research and you were, just a pure researcher as a professor graduating students, how much of that research actually ended up in product design? Or was it the knowledge transfer, or knowledge as in like just experience transfer? Did the research that you did in the labs turn out in the product? And is what is happening today, would you have any advice for that sort of research if they want to have that sort of impact?
Right. For Atheros specifically, actually, none of the technology we developed at Atheros was transferred from Stanford. Okay, as I said, we did a single chip GPS. So from that experience, we learned that CMOS with proper digital analog code design can reach gigahertz. Okay, and that was just the insight and experience that we gained. In terms of making impact, at least for me, as I said, I sucked in math, right? So I have always tried to work on projects that are meaningful in some way, the way I define it, okay? Meaningful means it can help somebody, okay? So to me, that seems the prerequisite of starting a project. When I started a single chip GPS project, that was a DARPA project, and I think if single chip GPS CMOS $5 chip, GPS back then was really fancy stuff, right?
Yeah.
So every kid have GPS, and when you get lost, and when old folks get lost, so there was always a kind of a twist as to the application side. And as to Atheros, as I said, it was really understanding the insight through that study that I think it was possible. Now come to the startup, okay? I thought about how hard has a startup has to be, okay? Before you start a company, of course, there's a market risk, there's technology risk. As a technologist, we probably have little control of market risk. But how much of technology risk are we willing to take? If there's no risk, that means you know exactly how to build this thing. Probably it's not going to be a successful startup. Because once you started, by all means, 20, 40 of them were just coming up after you. Actually, when we started Atheros, within a few months, about 45 companies working on Wi-Fi. Okay, so it had to be hard enough that you you actually, in my experience, you actually don't know what the solution is going to be. But you have to have enough insight to know that there's bound to be a solution, and I'm the first one to get that. Okay, so I think that kind of it's kind of a two-sided constraint. Okay, so if you made it too simple, don't even try. If you made it, of course, make it too hard, then your technology risk is too high. So I think that's the insight that professor actually would do very well, because we assess the success rate of our project.
Would you say there is, so in research, I work in a research lab, so the current philosophy, at least that I am solving, is that we still do research, but we do customer-focused research. And what I mean by that is sort of like we try to figure out, this is the general problem we're solving, and we kind of go to the people who are going to use it, and then keep asking them, what is this exactly that you need, and then try to solve the problem. So in academia, would you say there is room for something like that, or you think it is better to keep it the way it is, which is to sort of, I wouldn't say contrive, but come up with these,
My personal opinion on that one is, I think we have to lead the customers. Because, especially at least in my field, the customers had no idea what the technology is capable of delivering. As a professor, our project has to have a time span from 5 to 10 years. Because when I started an idea, my student won't graduate until 5 years later. I wouldn't want the student to give a talk and say, very nice work, but we've done it before. So the project has to have enough kind of a forward application. And I think very few customers in my field would know exactly what's going to happen 5 years from now. So my answer to your question in this particular field is probably not a good idea if you're going to start a company.
Let me ask you about something else. So I've heard you talk about flexible hardware. So I kind of know, like if you think about how you have done your research, there were some hardware issues that couldn't be solved, so you use software or signal processing, as you mentioned, to sort of fix those hardware issues. So if you take the complexity away from the hardware and put it more in, let's say, software, you're effectively starting to do software-defined radios. And so we've talked in this community and others, we've talked about software-defined radios for a long time. Where do you, but that reality hasn't really taken off. So where do you stand on this? What is your thoughts on that subject?
Again, I'm not expert on that, because all my life I've been doing pretty much application-specific hardware. Yes, we did provide a lot of programmability in our chipset, but that was actually controlling different piece of hardware. I think software-defined radio, software-defined network, anything that can be done by software, the hardware possibly is obsolete. So application-specific hardware actually is a function of time, of course. At different point in time and different application will use software and hardware. But the key thing, why I think software-defined radio didn't really shine, is really the power. If the power is high, though. Not going to work. So if the power.
So are you like one of the skeptics that were telling you that it was not possible?
If the power number is high, because power has this very interesting characteristic. It doesn't have to be lower all the time. It's a threshold thing. If the power is below certain number, it really doesn't matter. For example, for Wi-Fi, it has to be about 10% of less than 10% of your PC. So very quickly you can figure out what the Wi-Fi power has to be. So if you design a software-defined Wi-Fi with less than, say, 1 watt, sure. But that's not possible right now, because Wi-Fi does require 50 to 100 billion operations per second.
Okay, so now I'm going to turn a little bit on about leadership. Okay, so you're a scientist, you're a researcher, you're a professor, but you're also a leader. I mean, you have built this big company, people followed your lead. So I want to get some insights from you. So for the next question, I'm actually going to read something, because I don't want to get it wrong. Okay, so I wrote this. So when I was reading about you, this is how people described you. And I know you've told me multiple times that you are uncomfortable talking about yourself, and and I've heard from many people that you're one of the most modest person they know. So even though that has been said about you, and you told me not to say, I have to say what I'm going to say. Okay. So when people describe you, these are the words they use, and I'm not making anything up here. So I'm not sort of trying to come up with something. This is truly what people used. They said you're tenacious, you're humble, you're courageous, you're intelligent, curious, open, tireless, focused, and driven.
Wow.
And I thought that's pretty good, because if you think about, anyway, it's pretty good. So, wow. Now, Richard Hamming, which we all know, also said, a characteristic of a great scientist is that they have courage. They will go forward under incredible circumstances. And I think you have proved yourself that. I want to ask you, and this is relatively hard questions because you've gone through, but I want to ask you, what is the single most challenging thing you've had to face and you crossed it?
Well, the answer to this question, of course, depends on when I was asked, right? Now, given my age, given what happened in the past 30 years, I think the most difficult challenge that I have faced and actually survived and succeeded is actually being a woman in a male-dominated profession. I didn't set out to understand the difficulty of this. I didn't know. I was too young. I was the only professor at Stanford for many years. I had no reference point as to what the baseline is. But now when now I have more time after retirement, I look back, it was really, really, really hard to be a woman in our profession, in general. Okay, so I guess that's my most candid answer.
Okay. Okay, I don't know how to relate to that. So, but I can appreciate. Let's talk a little bit about culture, because leaders think about that a lot. So, for example, I work for Microsoft, and I very clearly see how Satya Nadella, who is the CEO of Microsoft, works very hard in trying to change a culture, create a culture of empathy and growth mindset. And in fact, he's written a whole book about it that he asked he passed it on to all the employees to read. And so he works on it on a day-to-day basis. I want to understand, what is your philosophy? What is your philosophy in life about culture of companies that are successful? How do you create a winning mindset in a company?
For Atheros, because the founding process was very rocky, and my co-founder left in the middle of it, so it was pretty hard. And so from that experience, I learned that mutual respect was probably the most important character that I was looking for in a team. So when I recruited this group of people, I think integrity is number one, teamwork is number two, and of course they had to be competent engineers. And I was very, very fortunate and lucky to have been able to find this group of people who none of us really care about personal credits, really care about who did what, whatever. We openly discuss, admit our mistakes, and moved on. So those several years at Atheros was the best experience I had in terms of working as a team. I feel I was covered, I feel I was safe. If I made a mistake, no worries, somebody will take care of it. If somebody else mistake, don't worry, I'll take care of it. That kind of mutual trust, mutual respect, to me was the most precious character of the ingredients of the team from the beginning.
So, in Microsoft, again, they do a yearly poll called MS Poll. And one of the key questions there is the other person invested in your success? So, and I think we get different answers, different years, but I completely get it, what you're saying in terms of doing the trust. Staying with the subject of leadership, I want to ask you about failures. Much is written, lots of books are written about you've got to fail to succeed, and failure is not a failure unless you learn from it. I would imagine behind every successful person, there is a list of failures that have happened. So you don't actually see those, but that definitely happens. Could you talk about one or two of what you've had and what you potentially learned from that?
Yeah. Well, given what I just told you, how I became an engineer, right? I wasn't prepared for it. I have plenty of failures in my life, and my share of it. Now when I think about, even back then I think about, why did I fail at those, for those occasions? And most likely because I made the wrong decision. Then I failed for doing something. Then I try to contemplate, why did I make those stupid decisions? And then over and over again, it was fear. It was fear of, I was afraid of not living up to other people's expectation. I was fear to embarrass myself. So I made wrong decisions to guard myself against something that's not really real. This was in my mind. So when things didn't go my way, I would try to reflect on what was the fear that made me make that wrong decision. And again, once I figured out what the fear was, I was lucky enough, I was able to address that fear and correct the decision. And once you correct the decision, of course, you will adjust your expectations. And the failures becomes what we call experiences. So I think my answer to that question is how I handle failure is really to ask myself, what was I afraid of to have caused the sequence of events that happened that caused the so-called failing experiences.
So now are you saying you no longer have that issue?
Oh, every day. I mean, no. I have that issue all my life. Yeah, it is an ongoing, I would say, dialogue with myself.
Are you a lot more reflective now in terms of, are you aware of that? And
yes.
Is that the thing that people maybe should back to be aware of what your
yes, I
fears
think with practice, with age, and also with time. I did retire 5 years ago, so I am more mindful about things and the decision that I make today than I was when I was younger, when I had to do things very quickly. I was reflective. We all know how busy we are all the time, the demands, the deadlines, and then you will miss a few steps.
Yeah.
When you miss a few steps, that's okay, all of us do. But in my example, it's helpful to come back to see where did I actually make the first fall. And usually, in my case, it's fear.
So you said a couple of minutes ago, you said something, and I didn't know how to react. But I've been thinking about what you said. What you said was about being the first woman in Stanford, not having mentors or not having a clarity of path that other women had followed that you could follow. So that made things difficult. So there's, I think, in my opinion, there has been a greater awareness now in the community about women. I actually went to the Grace Hopper conference recently. There were 20,000 women there. I was in a panel. It was a very refreshing experience for me, very nice. And there was this big notion of we are here. And what that really meant was that, look, we are ready, so this women, we are ready to take on these big roles, these leadership roles and things. So I want you to take like 2 minutes to sort of think about what advice would you give to young women, and not just young women, but perhaps even men, who are also here, about how to get us to a better place than we are, so that people don't have to struggle through regular stuff. I mean, struggling through technical, that's a different thing. So what would your general advice be?
I'm afraid this topic probably take more than 2 minutes.
I agree. I agree. But I couldn't resist myself, because when you said that, I just
Okay.
But take 2 minutes or a
Well,
little
let
more.
me think about this. When you ask the question, several things kind of flash over my mind. Actually, it's inevitable. It's going to happen. I don't think this prejudice against any minority, women, gender, whatever, is going to stop. Because human behavior, we just don't behave that way. So I think the only way, I think, that the gender discrimination will disappear only when half of the population, half our profession are women. The number speaks. Since we're still a minority, let's just talk about women as being a minority compared to, we'll talk hopefully other minority issues. Let me speak to the women first.
Sure.
Okay, then I probably have something to do with the guys as well. We all know the most blatant form of gender discrimination, harassment. No, we don't talk about that today. The most difficult form of discrimination is the subtle one. The very subtle one, especially coming from people who actually seeming to care about you, but fundamentally they just don't believe women can stand alone. Women can make their own stories. It is tough because this form of discrimination or prejudice usually came as advice. Okay, so women, I mean, myself included, really have to be very careful to differentiate advice that help us to reach our goal or the advice that simply serve to convince ourselves that we simply cannot do a man's job. You have to be very aware of the distinction because as a human being, especially a minority, it is tempting to believe a kindly worded advice. It is tempting to follow their advice. But if we do, we're willingly giving away our true potential. Okay, so I think that's the, it's difficult to explain that, but it happened to me so many times. Of course, it's not my job to educate these, like senior to me, that you shouldn't have said that, whatever, but you have to be very clear yourself, inside you, whether these advice should be followed or should be rejected. Okay. Then the second portion was probably even, I would say even more important, is once you know, whenever you feel that you're being unfairly treated, most likely you have been. Once you know that you have been unfairly treated or discriminated against, what are you going to do? My advice to the young ladies, also to men as well, if you feel you're unfairly treated, what are you going to do? All of us have only 24 hours a day. I picked the thing like pick your battle. Okay, when we get hurt, our emotions run high. After that wave's pass, you really have to think strategically, clear-headed, what is your goal? If you're gonna pick this battle, you better make sure that the goal is clear and that you can achieve it with high probability. Because these battles are tough. You'll be faced with obstacles, you'll be faced with all kinds of insult and society backlash. Do you have what it takes to stick with it? And therefore, pick your battle wisely, because that's your life that you're devoting to it. So pick your battle wisely, to me, I think is the most important, so that if it's not worth your energy in life, move on, because there are other things in life that we can enjoy and derive satisfaction. So be wise, I would say, be mindful about when things happen, and when you are in that situation, be very careful about which battle you choose to fight.
Thank you. I think that is that's great advice. I'm going to ask you, so I'm going to ask a couple more questions, but now you should start thinking about what you want to ask Teresa, okay? So you've been warned. But, so thank you for that. That was really, I think, pointed. So you said, don't know what when people are giving you advice, where, for example, where they're coming from and what sort of advice is that. So talking on the subject of advice, in 2015, you gave a commencement speech to NTU. Now, I actually went to YouTube to listen to it, but it was all in Mandarin. Yeah, Mandarin. It was all in Mandarin, so it's very hard for me to understand. I didn't understand. But what I did do is I actually looked at, there were lots of views, so it's a compliment to you, lots of views, and there were some comments on that. And I used translator services to sort of try to figure out what people were asking. So I'll ask you about that, but I also was curious as to what advice did you give to these young men and women who were graduating and going into the world? And I would imagine that advice is more than just to the NTU students. So for every student here, could you just tell us at the high level, what was the advice you gave?
First of all, that was a commencement speech, and that was given to undergraduate. Okay, so I don't know how many undergraduate students are there.
That's okay.
Yeah, but it was a 30-minute talk, so remember two main points. The first one was I asked the students to, once they graduate, because they're on the verge of graduation, to take on the most challenging job that they can find. I asked them to step out of their comfort zone, because neuroscience has indicated that only when we are faced with challenges will our neuron actually generate new connectivity and our capability improve. So if you're not challenged, you basically degrade, because the body and the brain degrade. So you have to be challenged. Challenge means you are given a task just a little bit harder than your capability feel comfortable with. So take on a tough job, and that's the best way to hone your skills.
I think this is good advice for any age. I don't think it's only for the students. I think we all tend to get comfortable in our comfort zone, we call, and then we basically limit our own selves by not doing it. So this advice, I think, is appropriate for any age. So one of the discussion that was happening in that in the YouTube video was, and I was curious to hear, and people had answers to that, but I was curious to hear what your comments were on that. Why did you decide to sell Atheros?
Okay. Atheros was founded in 1998. I think by 2009 and 10, we ran into a big issue. Wi-Fi is a peripherals. We never were able to design or produce a processor that would be a platform play. So at that point in time, the industry has consolidated quite a bit. Mm-hmm. So they start to have bundle deal. Bundle means, if you buy my Wi-Fi, I'll give you my Bluetooth. So Intel, Qualcomm, Broadcom, they all have other products. Atheros being very good in Wi-Fi, but we're actually still a single product company. We had a few other products, but they didn't have enough market share for us to use the bundle technique. So I guess around 2010, our business was great. Mm-hmm. And then we still enjoy at least 30-40% market share. But we realized that continue on for another 5 years, we probably would lose quite a large market share. And then, of course, we were trying to acquire other company. We did actually try to provide more product lines so we can also give better services, better pricing to our customers. But eventually, Qualcomm, I think their Wi-Fi acquisition basically failed, and they really needed the best Wi-Fi chipset to go with their cell phone chipset, and then that was I think that was acquisition that we had to make for the sake of employees. I think Atheros from day one is all about employees' benefit. Okay, so I think we're responsible for these thousands of families. Yeah. So it's our responsibility to make sure that we gave these families the best options that we can afford.
Yeah, that's great. Okay, so we are now at the end, so I have just a few more rapid-fire questions. And so all you have to do is listen to the question and choose or give one answer, okay?
What did I have to do?
There are a few questions where you just have to give a short answer, and then I'll give you multiple choice. But
Okay.
here's the deal. I picked these questions, but you already covered many of them, so it's shortened. But here we go. What is your favorite book?
Bertrand Russell, History of Philosophy.
Who's the scientist or engineer who's had the most impact on your life?
Can't answer that one. Probably Fourier. Because all my work is based on his work.
Of all the accomplishments in your life, which is the one that you're most proud of?
I'm most proud of. I would say probably founding Atheros.
Okay. Multiple choice questions, pick one. Licensed or unlicensed?
Unlicensed.
Okay. A student comes to you and asks you, should I do computer science or should I do electrical engineering? What do you tell them?
Your choice.
Student comes to you and asks you, should I do artificial intelligence or systems? What do you do?
Systems.
Another student comes to you and says, should I go to Stanford or should I go to Berkeley?
Berkeley.
Didn't expect that one. That's good. That's good. Blockchains or hash graphs?
I don't understand what that means.
All right. Alibaba or Amazon?
Amazon, because I use them.
Microsoft or the rest of the world? Okay, on that end, I wouldn't have her answer that one.
Thank you very much.
But we have a little video that we created in the last day or so. So could you just please play it with the volume high? Because I looked at it, you can't actually hear it.
Excited for you, and I'm so glad to be able to see you get this award. I think it is long overdue. You've come a long way. I know what it is like, being the one and only female professor when you first joined Stanford. Good for you, and thank you for being such a good colleague and friend for 30 years.
Hey Omid, have you heard of this year's OCA winner?
No.
She is super rich.
No way.
$10 billion.
No way, man. How come she made that much money?
Atheros, man.
Wow, that's impressive.
Yeah. Teresa, congratulations.
Congratulations.
Please fund our research.
Hey Teresa, at the National Science Foundation, we are extremely proud to have supported you from the early stage of your career all the way until now. And what you have done at Atheros and at Stanford and before 2000 and after and continuing on has been a source of immense pride for everyone at NSF and also the entire community. I can say that whatever you have done in all these years is going to have a long impact for the entire community for the next decades, few decades to come. Thank you.
Hey, well, have you heard of this OSA competition?
No, I think, maybe it was that Stanford professor who studies wireless. I think it was something that connects people together. Is it Wi-Fi? Oh, I think I've heard of that, yeah. Congratulations, Teresa, on your OCA.
Teresa, thank you and congratulations so much on your Outstanding Achievement Award and congratulations on your amazing impact on WaveLAN in the 5 GHz band. You have changed the course of our research community in immense ways and congratulations.
Hey, Suru, do you know this year's OCA winner? I hear she made some Wi-Fi chip.
Yeah, she made the Wi-Fi chip, Atheros.
Wow, that's the chip on my cell phone.
Yeah, not just your cell phone. It's a chip on billions of cell phones and laptops and you name it worldwide. It is low cost, low power, and she took the cost of a Wi-Fi chip from several dollars to few cents. That's amazing.
That's amazing.
Congratulations, Teresa.
Congratulations, Teresa. I'm so glad that you're getting this OCA award. Atheros, in particular, changed my research career in many ways, and I think it changed our lives in very significant ways. So thank you and congratulations again.
It is so great to be here in Delhi to help Teresa celebrate the amazing accomplishment and award that she just received. I've known Teresa since she started at Stanford, I remember she came to Berkeley when I was a graduate student to talk about what it was like to be a new professor. I followed in her footsteps behind her. She started Atheros, I started Quantetta. We were competitors in business, but always friends and colleagues. I have the deepest admiration for everything Teresa has done, and I'm so delighted to see her work at Atheros and her contributions at Stanford and her research recognized in this prestigious way and in this wonderful city. So congratulations, Teresa.
Hey, Teresa.
You're outstanding. Outstanding.
All right. So, yeah, let's give a grand applause to our OCA 2018 winner. So at this point, I'm going to invite the chair of SIG to actually hand out this beautiful award that we have for her.
Teresa, for sharing this amazing story of your career.
And I'll also like to invite Rajiv, if he's here, to give you a little bit of a gift for enduring through this grueling interview. No, I hope it was great. Rajiv. Yeah, so hey, we are not production artists. We are obviously not actors, we can see. But our heart is in the right place. We want to wish her the best. Thank you very much for everything and keep rocking. Okay, that's it.